It should be bright. Every direction you look should blaze like the surface of the sun. And yet, when you step outside at night, it's dark. Pause there for a second. Don't rush past it. The universe is filled with hundreds of billions of galaxies. Each galaxy with hundreds of brains at stars. That's a poetry. That's observation. The night sky should not be mostly black with scattered points of light. If the cosmos were infinite, eternal, and evenly packed with stars, every line of sight from your eye would eventually land on a star's surface. The sky should glow. Doesn't.
This puzzle has a name in physics, Olbers Paradox, but imagine hearing it the way a curious mind like Feynman might frame it, not as a dusty paradox from the 1800s, as a living contradiction, a quiet, unsettling question hiding above your head every night. Why is the universe dark? Feynman had a way of taking questions that felt abstract and turning them into something almost personal. He would not begin with heavy equations. He would begin with common sense. Look, he might say, if you're standing in a forest that goes on forever, and it's packed with glowing trees, how could you possibly find a dark spot to look at? You couldn't. So either the forest isn't infinite, or it hasn't been glowing forever. For centuries, many scientists assumed the universe was static and eternal. No beginning, no end, just endless space filled with stars. That picture feels stable, comforting, like a stage set that never changes. But if that were true, darkness would be impossible. Imagine drawing an imaginary line from your eye straight into space. That line travels outward, past the moon, past the sun, beyond our galaxy. It keeps going. In an infinite universe, that line must eventually hit a star. And not just your line, every line in every direction. Multiply that by infinite stars and infinite time, and the night sky becomes a wall of fire. Yet when you look up, you see blackness pierced by light. The darkness is not an absence of explanation. It is the explanation. Feynman loved that kind of twist, where the thing you ignore, the empty space, is the real clue. To understand the darkness, you have to accept something radical. The universe is not eternal in the way people once imagined. It had a beginning, not just stars turning on one by one, not just galaxies forming gradually, a beginning of space itself. The idea gained serious traction in the 20th century, when astronomers observed that distant galaxies are moving away from us, not randomly, systematically. The farther away they are, the faster they recede. Space is expanding. Now imagine running that cosmic film backward. Galaxies draw closer. Distances shrink. Temperatures rise. Go back far enough and everything compresses into a hot, dense state. Not an explosion in space, but an expansion of space. The Big Bang. Here's where the darkness becomes meaningful. Light travels at a finite speed, about 300,000 kilometers per second. Fast, but not infinite. When you look at a star 1,000 light years away, you are seeing it as it was 1,000 years ago. When you look at distant galaxies, you are looking back millions, even billions of years. Now push that logic to its limit. If the universe is about 13.8 billion years old, then light has only had 13.8 billion years to travel. There are regions so far away that their light hasn't reached us yet. Some lines of sight from your eye simply haven't encountered a star's light. Because the light hasn't had enough time to arrive. Suddenly, darkness isn't mysterious. It's historical. You are staring into regions of space whose light is still on its way. Feynman would appreciate the elegance of that. The idea that darkness is not emptiness but delay, not nothingness, but unfinished communication across cosmic distances. But that's not the whole story. Even within the observable universe, the part we can see. Why isn't the accumulated light overwhelming? Because space doesn't just expand, it stretches light. As galaxies move away, the light they emit is redshifted. Its wavelength elongates. Visible light shifts into infrared. Infrared shifts into microwave. Energy spreads thinner and thinner across expanding space. That means even though the universe is filled with radiation from its hot beginning, much of it is no longer visible to your eyes. In fact, the sky is glowing right now, not in visible light, but in microwave radiation. The cosmic microwave background, a faint afterglow of the early universe, cooled and stretched by billions of years of expansion. If your eyes could detect microwaves, the sky would not look black at all. It would look softly luminous in every direction. Darkness, then, is partly biological. Your eyes are tuned to a narrow band of wavelengths. The universe shines in frequencies you cannot see. That feels like something Feynman would grin about. The idea that reality isn't hiding from you. You're just poorly equipped to notice it. There's another layer. Stars do not burn forever. They have lifetimes, millions to billions of years. They are born from collapsing clouds of gas. They shine by fusing hydrogen into helium. Eventually, they exhaust their fuel. Some swell into red giants. Some explode as supernovae. Some collapse into white dwarfs or neutron stars. An eternal universe filled with stars would require eternal star formation. But stars consume material. Gas clouds thin out. Energy disperses. A static cosmos packed infinitely with shining suns is unstable. It cannot sustain itself indefinitely in that state. So the darkness tells you that stars have ages, that galaxies evolve, that the universe changes. Feynman often said that the imagination of nature is far greater than the imagination of man. This problem proves it. The simple expectation, infinite stars, mean infinite brightness, fails because the universe refuses to be simple. It expands, it ages, it transforms. The night sky becomes a historical document. Each point of light is a message from the past. Each patch of darkness marks either distance beyond reach or wavelengths beyond perception. And here's a thought that might have fascinated Feynman most of all. In the far future, the sky will grow darker. As expansion accelerates, distant galaxies will slip beyond our observable horizon. Their light will stretch further into invisibility. Eventually, observers in the distant future, if any exist, may see only their own. Galaxies surrounded by blackness, unaware that countless others once filled the cosmos. Darkness is not permanent. It evolves. When you step outside and see the Milky Way arcing across the sky, you are witnessing a brief era in cosmic history, a time when stars are abundant, galaxies are visible, and expansion has not yet erased the evidence of structure. The paradox dissolves into perspective. The universe is not infinitely old. Light has not traveled forever. Space is stretching. Stars are mortal. Put those pieces together and the black sky stops being a contradiction. It becomes confirmation. Feynman would likely remind you not to treat this as mystical. There's no need to romanticize the darkness. It's not a cosmic secret whispered only to philosophers. It's physics, measurable, testable, predictable. And yet there's something quietly profound about it, because every time you look into a dark patch between stars, you are seeing the limits of time itself, the boundary of what has had time to reach you, the edge of the observable. The darkness is a horizon, and horizons are not walls, they are invitations. The question, why is the universe dark, turns out to be a disguised question about beginnings, about expansion, about the finite speed of light. It forces you to abandon the comfortable image of a static, eternal backdrop and replace it with a dynamic, evolving cosmos. That shift from static to expanding was one of the greatest revolutions in science, and the night sky carries the evidence quietly. Every evening, above every city and desert and ocean, the stars are not enough to brighten infinity, because infinity is not what we have. We have a universe with a history, and history leaves shadows. So the next time you look up and notice the blackness between stars, don't dismiss it as empty space. Recognize it as testimony, proof that the universe began, that light travels, that time has limits, that expansion stretches reality itself.